Hello everyone, welcome back to this lecture series on the thermodynamics. This is Dr. Rahul Srivastav, Assistant Professor, Department of Physics, Bhopal School of Social Sciences, Bhopal. In this particular lecture series, we are going to discuss about the heat engine, and this is our third lecture of this series. And this is our today's plan of talk, in which we are discussing first one, the introduction and basic properties of heat engine is, and what is the working process of this heat engine. Then after, what are the various aspects and major part of this heat engine, that is followed by the source, sink and the working substance. Then after, we will calculate the efficiency of our heat engine. Let me start with the basics of the heat engine. A heat engine is an engine which is continuously convert heat into mechanical work. This mechanical work is actually a rotation of wheel or the motion of piston from lower down side to upper side, or we can say that the mechanical work is a cyclic 360 rotation of a particular substance or a material. So this is what our heat engine is, and this continuously does this mechanical work in a cyclic process. The meaning of cyclic process is it's returned back to its original place when the one cycle of the work has been complete. So this is what the heat engine's definition is. It is having mainly three parts, that is source, followed by the sink, and lastly the working substance. Thus this particular heat engine takes heat from the source, then does some work like moving a piston, lifting weight, etc., and finally discharge some waste heat or the rejected heat towards the sink. This is what the image of an heat engine is, and you can clearly see that the energy or a heat coming from the source towards the working substance or an engine. This engine absorbs the heat coming from the source and convert it into the required mechanical work. Then in this process we will have some, or the engine produce some rejected heat as a sink. So let me give you an example that source can be considered as a fuel tank of a particular moving object like bike and car. So sink can be considered as a silencer, the rejecting heat. So just like our fuel engine provides petrol or diesel to the engine, that this burning process happens, and we will have the mechanical rotation, 360 rotation of our wheel. So engine actually working on this concept. So we can say that source is the input heat provider to the engine, and sink is like a silencer of a particular engine that is rejecting the waste heat. So let me start with the description of the source. That is, it is a heat generator or heat provider. As we have discussed, this is the input heat provider for the engine. Generally it's found in very high temperature, that we all know the phenomenon of energy that always travels from higher temperature range towards the lower temperature range. So generally we put this source on a high temperature range so that the heat can transfer from source towards the engine easily, so that this particular source is found in very high temperature range, and the amount of heat can easily extracted from this particular regions towards the engine. The temperature in this whole process is remain constant. The source temperature always remain constant in this particular process. Then after, the sink, it is a heat remover or the waste heat rejector, that is continuously rejecting the heat coming from the heat engine, and it is generally found in very low temperature side. So this can accept any heat that is coming from the engine towards the sink, so that it can remove easily the rejected heat. The amount of heat that is providing to it, whether it is having lower temperature value or higher temperature value, since we have put the negligible or the lowest temperature value of the sink, so it can accept any heat, can remove easily also. So is in the sink, the temperature also remain constant in the whole process, so that the temperature can easily be accepted or easily can remove the heat also. Then after, we are having the working substance of an heat engine, the substance which absorb heat from the source, that is coming from the input source and converting into the mechanical work, is known as the working substance, and this particular section we know it as an engine that is converting or creating the mechanical work. it absorbs, as from the image we can see that it is absorbing the heat Q1. The Q1 is the heat that is coming from the source, and the temperature of source is T1. We are taking it as an values and converting a part of this particular heat, and this engine is absorbing this heat and converting it into the mechanical work, and we are denoting it as W, and rejecting the waste heat Q2 that is going towards the sink. So, or the temperature of sink is we are taking HT2. So, the T1 and T2 temperatures are constant, they are not getting change in this whole process, and the flow of temperature, or we can say that the heat, that is the Q1 coming from the engine, and Q2 that is going out from the engine towards the sink. This whole process is a cycle, and in this phenomenon the work has been completed one cycle, or we can say that our wheel has been rotated 360 once, and the engine comes back to its initial position. As we have discussed, this is the cyclic process, so that the working substance is returning back to its initial state, and this cycle continuously repeated, so that we are having the movement of our vehicle or an object, because it is a continuous cyclic process, and we are seeing that substance is returning back to its initial state and temperature is remaining constant. So, as we have discussed in the previous lecture, according to the first law of thermodynamics, if temperature remains constant, as this particular section I have zoomed about the isothermal process, in which once temperature is getting constant, temperature is not getting changed, means there is not any change in internal energy also. The internal energy you will remain constant, and the change in internal energy will be equals to 0. So, the equations of the first law of thermodynamics is dq is equals to du plus dw, where dq is the importing heat, and du is the change in internal energy, followed by the dw is the total mechanical work done whatever we are having by this engine. Since as I have told that u is not getting changed, it is a constant value, so du is equals to 0. We are putting this du in our first equation, that is dq is equals to du plus dw, or we can say that dq is equals to dw. So, the whatever heat is getting changed, it is completely converting into whatever the work done we are having. That is what the first law of thermodynamic equation is providing for the heat engine. Now, in this entire process, the heat is basically changing from Q1 to Q2. That is, Q1 is coming from the source towards the engine and converting and changing into the Q2 towards the sink. So, Q1 and Q2 are the two heats, that is the change in heat from Q1 to Q2. So, we can say that dQ is equals to Q1 minus Q2, or change in work done or the resultant work done dW is equals to Q1 minus Q2 also. So, this is what the working substance of an heat engine is. After that, we are going to calculate the efficiency of our heat engine, that how efficient our heat engine is and how we can calculate the efficiency of a particular heat engine. So, the ratio of work done, the definition is the ratio of work done by the working substance. So, whatever the work done we are having with respect to heat absorbed from the source is known as the efficiency of heat engine. Mathematically, we can say that eta is equals to work done. Eta is actually a symbol of representation of efficiency. So, eta is equals to work done, whatever the work done we are having in one cycle, upon the heat absorbed by the system or an engine. Mathematically, symbolic representation in which we can say that eta is equals to W upon Q1, where W is the work done and Q1 is the heat absorbed. The engine is absorbing heat that is coming from the source. So, W upon Q1. That in this W we can put Q1 minus Q2 as we have discussed previously. So, eta is equals to Q1 minus Q2 upon Q1, or further we can solve it as eta is equals to 1 minus Q2 upon Q1. So, from this equation we can say that for the 100% efficiency, the eta must be equals to 1, or for that eta is equals to 1, the Q2 is equals to 0. So, that we are saying that the heat rejected by an engine is 0, means that whatever the heat is coming from the sun towards the engine from the source, that completely we utilized, and the resultant output is always converted into the work, and there will not be any rejected heat there. So it is completely impossible. It is just an ideal theory, and practically it is not possible. So we can say that there is not any 100% efficient system towards us that is converting completely source energy into the mechanical work, and there is not any sink energy. So in practice we can say that there is not any still heat engine that is 100% efficient, and the efficiency of an heat engine is always less than 1. In percentage we can say that it is always less than 100%. So this is what our today's lecture is, and we have completed this heat engine today, and in the next lecture we will discuss about the Carnot's heat engine. That is the first engine that is demonstrated by Sadi Carnot's, and we will have the detailed description of it. For today, this is Dr. Rahul Srivastav from BSS Bhopal signing off. Thank you.